Okay, this is the first problem of our review. I'm going to be breaking these videos into problems of maybe like 10. So let's get started. The first problem says solve this by using substitution. The first equation is all set up to solve it for x. All we need to do is add this y to the other side. So we'll end up with x equals negative 11 plus y. Okay? So then we can take this right here and substitute it in for x in the second equation. 7x plus 4y equals negative 22. Okay? We'll put the negative 11 plus y in for x. Okay, now it's all just algebra. You're just going to basically distribute the 7 into the y. Okay, I'm just going to work quietly here for a second until I get an answer. Add 77 to both sides. Okay, so at this point you have half of the answer because these two equations intersect at a point. So there are two lines, they come together and meet at a point. You only have half the point, so you only have the x part, or I'm sorry, the y part of the answer. You need to go back and find the x part. So you'll do that by taking y and plugging it into one of the equations. I think it's easiest to plug this into this equation. Okay, so we have x minus 5 has to equal negative 11. And when we add 5 to both sides, we get negative 6 for x. So the answer is right here. Okay. Problem 2 is also set up for substitution quite easily because it already says y equals. So we're just going to put it right in. 2 times 7 minus 3x for y. Okay. And at this point, it's just all algebra. So we'll distribute the 2 and get this. Negative 6x plus positive 6x is nothing. So this is again with 14 equals 14. And in a situation like this, that's quite odd. There's no x equals, there's no real answer here. So when this happens, doing substitution, it means that there are many solutions. What's happening here is weird, but at least 14 does equal 14. It is true. Visually, you have one line and you have a second line that is right on top of it. And there are many, many, many solutions to where these lines intersect. So this is what will happen if you use substitution and it ends up having many solutions. It'll end up being like 14 equals 14 or 2 equals 2 or something like that. Okay, our next set of problems wants us to use elimination or the addition-subtraction method. So to do that, we need to first set up the equations need to be stacked vertically like this, and we need the coefficients to be the same. So in this problem, I think it would make sense to take the first equation and multiply it by the whole thing. Multiply this equation by 2. So distribute the 2 to the 2c, you get 4c. Distribute the 2 to the 3d, you get 6d. And 2 times 2 is 4. So now we can ignore the first equation. Okay? Just kind of ignore it for right now. And look at the second and third equation. We can either add or subtract them. Now, we should probably subtract because 4c minus 4c would eliminate the c's. So the c's are gone. Now we have negative 9d minus 6d, that's negative 15d's. And we have negative 1 minus 4 is negative 5. Okay, there's a little equation there. We'll divide it by -50 to solve for D. And we get 1/3. Now again, that is only half of the answer. Okay? So what we need to do, once again, is we need to take that 1/3 and put it in for D. Take it, put it in the original equation before we multiplied by 2. So 2C plus 3 times D, D is 1/3, equals 2. Now 3 times 1/3 is just 1. Subtract 1 from both sides. End up with this. Divide by 2. We'll get a half. So here's the answer. That's the addition subtraction. Here's another one, number 4, that we can try. Now, number 4 is a little bit harder because you can't multiply either of these equations by a single number and get the coefficients to line up. So what you end up doing is you multiply both equations by some number. And I'm going to choose to multiply the top equation by 6. And the bottom equation, I'm going to multiply by 5. And watch what happens. Multiply the top by 6, you get 30x 18y equals 132. Then you multiply the bottom by 5, you get bottom equation by 5, you get 30x minus 35y equals 205. And so now this is good because you can see that the x's have 30x and 30x. We can subtract them and they will be eliminated. And then we'll only have to deal with one letter. So negative 18y minus negative 35y. That's where some people mess it up. Look at that. That's negative 18y minus negative 35 plus. Ends up being 17y's. And then 132 minus 205 is negative 73. And if we divide both sides by 17, we get y equals a really, really messy answer. Okay, I'm going to leave it in fraction form, negative 73 over 17. That is the answer. To find the other part of the answer, you'd plug it back in for y, one of the original equations, and you get x equals 31 over 17. So I'm not going to do that because it's a really, really messy process. And quite honestly, I just don't see a problem like this being on the test in terms of it being such a bad answer, such a, like an improper fraction like that. It's really, this one's a mess. So good practice, but I don't know how realistic it is for the final.